Hello, I'm going to talk about SDN-enabled drone base station. Let me tell you some backgrounds about drones or unmanned aerial vehicles or UAVs. Um, these devices are considered key instruments in emergency situations such as search and rescue, surveillance, and various scientific applications and such like. One of the promising applications of the drones is to provide temporary coverage for cellular networks because a static base station cannot serve all users due to temporary events. Hence, to resolve these issues, the controllable drone base stations or DBS equipped with small cellular base stations are instantly sent to the target location and establish the necessary communication links and cover that area. Finding the optimal location and the appropriate number of DBSs is a challenging issue in cellular networks. Let me show you the network architecture and model. Here I consider a scenario where a set of terrestrial base stations are out of service in the aftermath of natural disasters or such like. So in these situations, DBSs are deployed to the existing network infrastructure. As you can see here, we have two parts, data plane and control plane. In the control plane, the coverage modeling, traffic modeling, and so on can be considered. And in data plane, let me show you. We know cellular network or a dense network are the dense networks, but for the sake of simplicity, I've only considered 15 users that are mobile and 3 base stations. In some situations, as I've already mentioned, some base stations, for example, BS1 and BS3, are failed and are out of service. So in this situation, we should send the drones to cover those areas. Finding actually there are some baseline methods for finding the optimal location of the drones. There are some methods here. Actually, the simplest one is to send send the drones to the same location of the previous destroyed static base stations. Other research use the circle packaging approach, and the most important and hardest part is proposing a new deployment algorithm. For the simplicity, I've chose the first one, and I've sent the drones to the locations where the base stations were failed. As well as this, I've tried to implement a small congestion mechanism. Consider you assume that user one wants to send a high rate iPref traffic to user 4. Actually, here I tried to implement to have an implementation of explicit congestion notification. I mean ECN. So for doing so, we should first split the TOS field into two fields, GIFServ and ECN fields, and then we should update the checksum block accordingly in the P4 file. And finally, in egress control block, we must compare the queue lengths with ECN threshold. If the queue length is larger than ECN threshold, the ECN flag will be set to 3. Actually, you either put the value of 1 or 2 in the IPv4.ECN field. For such packets, each drones or base station may change the value to 3 if the queue size is larger than the threshold. I've tested it, but I don't know why at the end of the day the ECN field uh, was not set to 1, 2, or 3. I'm checking it, and this is the end.